Good. Let's get started. I would like to invest this cover lesson into talking a little bit about some language details of C#, which might be relevant and useful for you in the future. Let's do some very simple coding, okay? Let's first create an array with integer numbers. That works. Numbers, of course. That works in C# like that. Good. Now, let's write a helper method. I can show you another feature of Visual Studio. I'm not sure if you are aware of that. If you, for instance, say, you think of, I would like to write a method that does print even numbers, so print all numbers which are even, gerade Zahlen, numbers. You can just write the call of the method and then press Steuerung Control dot, and then you can just say generate method and it will automatically generate the appropriate method for you. This is somehow interesting and somehow useful, and there we want to do the following. We want to iterate over all numbers and print all even ones. How would you implement that? Yep?
I would have two.
Just one. Just give me one.
Well, you could divide the number by 2. And if it's,
yeah, remainder modulo. That's clear. But which kind of loop would you use? 4. Okay, let's do that. For var I equals 0, I lower than numbers dot length, and I plus plus, something like this, and then say if numbers I modulo 2 equals 0, then it's an equal number, and then we do CW. Did you see what I did? CW tab will automatically give you a console write line. Numbers I could do something like this. Would it work? Let's give it a try. Hopefully it will work. Yes, 2, 4, 6, 8, it works. Is it optimal? No. We have a bunch of things which are not optimal here, and the first one is this one. There is a principle in software development, and that applies not only to C#, but to all programming languages. Require the least specific type that you can handle. In our case, we require an integer array. Imagine that a caller has a list of integers. The caller cannot use your method anymore. That's a problem, right? Then you would need another implementation which gets a list of int. That's not optimal. Require the least specific type that you can handle. Is there a common base type that is implemented by all collections in C#? Yes, there is. And this type is called Enumerable. Enumerable, something like this, of int. Enumerable is implemented by any kind of collection. An array, a list, a dictionary, everything that stores a bunch of things implements Enumerable. What is Enumerable? Enumerable is a read-only, forward-only cursor. So you can only read from this variable, and you can only move forward. Next, 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 next. You cannot move back. Previous, previous, not possible. You cannot directly index it. Give me index number 3, not possible with Enumerable. And you cannot write, as I said already. So this is the least specific type we can handle. And if we have an Enumerable, we can change the type of the loop. So I change your suggestion a little bit, and I say for each. Var number in numbers. That looks better. For each means iterate over this Enumerable, and for every loop iteration, give me the number. You get it? So I get 1, 2, 3, 4, 5, 6, 7, 8, and so on. Clear? Good. Now I can simplify that one. Number modulo 2 equals 0 and number. Let's give it a try if it works. Well, of course it works. Yes, works. Clear so far? Always require the least specific type that you can handle, Enumerable. Good. Now, if we take a look at this method here, then this method is spaghetti code. It's a mess. Why is it a mess? we have some business logic, something like this, and UI, something like this, mingled into one and another. Get the idea? Imagine you have to write an automated test whether this function works or not. It's pretty complex. Why? Well, what is the return of this function? Void. How can you automatically test whether it works? You have to somehow scrape standard out and somehow gather what's written to standard out and parse it again, and it's horrible. This is called spaghetti code. Why? Because we mix business logic and user interface. In this case, a very simple user interface, just a console write line. Get it? So, suggestions. What could we do to get rid of the spaghetti here? You have a suggestion.
We could implement a method which filters the numbers and returns an array.
Good. Return an array. Good. Static int array, something like this. Let's rename this method. Let's no longer call it print even numbers, but let's call it filter. You said filtered. Okay, let's call it filter. That's fine. We shouldn't do a console write line here anymore. Let's get rid of that one. So we need a result. Good. Result equals new integer array. Something like this. Well, what is the size of the integer array? A C# array cannot grow in size. Not like in JavaScript. You need to specify the size of the array at the beginning up front. We have a problem, right? We have a list of numbers and we don't know up front whether how many of them are even. So somebody has an idea? Maybe array was not the best return type.
I'm not sure how the type is called in Sharp or some kind of list.
Exactly, and the type is called list. So what we can do is we don't return an integer array, but we return a list of integer, right? Something like this. Good. Then we can say we have a list of integer. Whoops. Good. And then we can say result.add number, something like this. And at the end we say return result, right? Good. And now we store the result, var result, and then we can for each across the result. For each var item in result and do console write line item. I think this is what you meant when you said let's do a filter method, and exactly. Now we don't have spaghetti anymore. We have one noodle up here and down here and one noodle up here. They are nicely separated. They are not mingled into each other anymore. Might be still spaghetti code, but they are now neatly organized. So that's fine. Much better. Let's give it a try. Good. Works. Now, this method, unfortunately, is not very optimal. Not very optimal is good. It's bad. It's bad. It's considered bad C# code. Why? Because in C# you don't need to build a persistent result in such cases. What you can do is you can return not a list of int, but you can return an IEnumerable of int. And remember what IEnumerable is? The base class for any collection. It still works because list is of course an IEnumerable. But now comes the magic. Get rid of the list, get rid of the return, and do the following. Yield return number. Yield return. Yield means ernten in German. That means the following. The method will examine the first number. If the first number is okay, it will immediately return the first number. Then the first number is printed, and once the second number is examined, C# will jump right into the method. So it will jump between the caller and the callee, one into the other, and back and forth all the time. Let me show you what I mean. Let's set a breakpoint here, and let's say debug. Good. My my laptop is already getting hot. I like that. So, come on, breakpoint. Hit the breakpoint, please. So here we are. You see, I press F11 means step into. I'm stepping into the filter method now. Now the system examines the first number. Is the first number an even number? No. Examines the second number. Is the second number an even number? Oh yes. And now look what's happening. Yield return. Jump out of the method. I'm now in the caller method again. See that? Now it prints the first number. And now look what's going to happen. F11. And the system does not jump into the beginning of the method. Not here. It jumps right at the place where it left the method at the yield return. Got it? So it jumps back and forth. That's the idea of yield. And if I continue that stuff, it should work. It should print the right numbers on the screen. Well, yes, it prints the right numbers. Good. Now let's take a look at the filter method. A closer look at the filter method. If you would need to describe the job of the filter method, how would you describe it? Imagine you have to write a single line of documentation in front of the filter method. What is the summary of this method? This method, ... What would you write? Yeah, okay. Returns every even number in the list of numbers. Okay, I agree to that. If we are a little bit more specific, we could say iterates over all numbers and return those numbers that are even. Get it? Now, in software development, there is a very, very important principle. Single responsibility pattern. That means everything you program, every method, should have a clear and single purpose. Now I said iterates over all numbers and checks whether the number is even and returns the number if it's even. That's not a single responsibility. We currently have in this method two responsibilities. We have one responsibility which is iterate over all numbers, and we have another responsibility which says check whether the number is even. Get it? Can we somehow make it really a single responsibility pattern? Yes, of course we can. This was a rhetorical question. I would like to show you what I want to show. What we can do is we can take this expression here, this one, and make it a function. So what we can do is we can say private, my laptop is so slow. Private static bool is even int number, and this is return number modulo 2 equals 0. Get it? And if we want to simplify that a little bit, we can make it an expression bodied member, and it looks like this. It's the same. I just got rid of the return. You see what I did, right? I just deleted the return and the curly braces, that's all. So now I can say here is even. Good? It's a little bit better, but still not good. Now my next requirement is, okay, that looks good, but now I'm as a user, I would like to display not all even numbers, but all odd numbers, die ungeraden Zahlen. What do we have to do? We could copy the entire filter method. We could write a method is odd, which of course says number modulo 2 not equals 0. And then we have duplicated a lot of code, right? How can we solve that? Do you understand what I mean? Now I would have to copy this whole stuff to make it very, very clear. I can say filter odd, for instance, and here I need to say is odd, and then I need to write the method is odd. That's just, okay. Anybody has an idea how we can get rid of this code duplication?
We could use a delegate so the user can
Yes.
specify.
I like that idea. What we can do is we can use a concept from functional programming. We could say, hey, does it really matter? Does it really matter which method is called here? In general, we could say, if we have a method that we can give an integer, and this method gives us return a Boolean, whether we should take it or not, we are fine. Is there a possibility to let this method somehow be injected into our method? And yes, this is possible. And in C#, you write it like this. You say, I want to have a function that receives an integer and return a Boolean, and let's call it predicate. So those functions are often called predicate. And then we can say predicate. So we get a function delegate, a function pointer if you want, as a parameter. And now up there we can say, hey, please use the isEven method. And if we need a different version, we can easily implement isOdd and just pass in isOdd. You get the idea? The name for this is called the strategy pattern. Why? Because the strategy of finding out whether this number is relevant or not is passed in as a parameter in the form of a function pointer. Get it? Now, I will show you some magic. Look closely. Copy the implementation of isEven. Replace. Woohoo! That's cool, isn't it? And then we can get rid of this guy down here. We only need a slight change because we need a lambda function. Essentially what we do here is we inline the function definition. You get the idea? So we don't need a function here. If we want to change this to odd, it's very simple because now we can just change this one and we are good. So this step was a little bit more difficult. Did you understand it? Now let's talk about the magic that the C# compiler does. Let me first show you something. If I hover over number here, the C# compiler tells me this is an integer. How does the C# compiler know that number is integer? I never said that number is integer. Why does it know that it is integer? Well, the first thing that it does, it looks whether I have specified a type here. Did I specify a type? Nope. Next thing, it says, okay, what is this call here? Filter. Ah yeah, I know filter. Filter is this method down here. Now what is the second parameter? It's predicate. What is the type of predicate? Yeah, it is a function, and therefore I know that the first parameter to predicate will be an integer. And therefore it can understand that this integer can be applied to this parameter. Get the idea? So you have full type safety across lambda expressions with functions. Hard to understand? A little bit. The nice thing is it's Harry Potter programming. It just works. You don't have to care. The C# compiler does its very best, and it does an extremely good job in finding out what the type of the variable is. Of course, I could specify it. I could say int number. Of course, I could do that, but it doesn't make any sense. It's not necessary. Why should we? We could, but we shouldn't. Any questions? Yeah, question.
In the filter method, we wrote the predicate. So does it mean the last type, in this case the bool, is the return?
Exactly. That's a convention. The last type in a func specification is always the return type.
So if
we could say that
types, the first two
exactly. If we say func int bool, It would say get 2 integers and return a bool. I always describe this kind of programming with Aschenputtel, with the tail Aschenputtel. I have to switch to German. It's impossible to do that in English because I don't know how it works. Aschenputtel kennt ihr sicher alle. Ja, da heißt es, wenn die Tauben daherkommen und da liegen die ganzen Getreidekörner am Boden, heißt es die Guten ins Zöpfchen, die Schlechten ins Kröpfchen. This is a Lambda method. We tell the Taube, dove, I think, we tell the dove that it should go through each, I stay in German for that, also einfach jedes Getreidekorn durchschauen, die Guten ins Töpfchen, die Schlechten ins Kröpfchen. This is a Lambda method. Take one, iterate over all the grains, and for each grain do exactly that. Is it good? Then put it somewhere. Is it bad? Eat it. Get the idea? This is exactly our predicate. The input would be a grain corn. The output would be put it somewhere else or eat it. Boolean, eat it or not. Get the idea? That's exactly what we do here. We have a for each loop executed by an animal in this case. You get the idea? So whenever you think of Lambda methods, think of Aschenputtel. Good? Are we done? No, we just begun. If we take a look at the filter method, it's not optimal. Still not. Why? Well, I have a question. Imagine that we don't get numbers. Imagine that we get strings. Enumerable of string, func of string and bool. What would change in the implementation of the method if the data type changes?
Basically nothing because we're using var.
Exactly, nothing. Not just basically nothing, nothing. Absolutely nothing. So what we could do is we can take this one, we could duplicate it, we say filter strings, then we change into string, we change the into string, and we change this into string, right? And of course, yeah, numbers is not a good element here. Let's call it just items, okay? Because it can be anything. Now compare these two implementations, please. There is another super important principle when it comes to software development. It's called don't repeat yourself. It doesn't make sense to duplicate code that looks extremely simple, extremely similar, or even identical. So this is not a good idea. You have an idea how we could fix that? With generics, exactly. What we can do is we can say, filter, let's make this a generic method. Let's add another parameter. Let's make the data type integer. Let's make the data type a parameter. And we do that as follows. The type parameters are written like that. Now we call the data type t. Whatever t is, we don't care. And then we can use the type parameter wherever we specify the parameter. And again, I'm renaming numbers to items because it's no longer numbers. And now it looks really good. Let me show you what I mean. It still works with our numbers, but it works even better. Result 3 equals to filter. And now let's define some names. And now we can say filter names, name goes to name, starts with t. So we can now use exactly the same method, one with numbers and one with strings, name, because the method implementation doesn't change when we change from integer to strings. You get the idea? That's a pretty powerful concept. That's a pretty powerful concept because with that you can write really generic methods that can be applied to a wide variety of situations. Questions? Clear so far? I am still not happy. I am still not happy because we can do a slight change that makes it even more beautiful. And this change is just one keyword. This. Okay, nothing changes. Oh, let me change that to a static class because we only have static methods in it. I just added this and it still works. Everything is fine. So I didn't achieve a lot. Well, I achieved something. This method injects, now listen closely, it injects this method into this type. So let me show you what I mean. I can now copy this first line, that's point result 4, and now change the syntax. I can now remove the name of the method here, and I can write dot filter, and if you take a very close look, I cannot zoom in here, and this method has a small arrow beside it. See that one? That means it is an injected method, and this is how you call these things. You call it an injected method. I have to switch to German again to give you a picture. Ich nenne das immer ein Kuckucksei. Kennt ihr das? Der Kuckuck, der Vogel, legt anderen Vögeln Eier ins Nest und lässt diese dann diese Vögel diese Eier ausbrüten. Dann braucht er sich selber nicht drum kümmern. Deswegen sagt man ein Kuckucksei. Ein Kuckucksei liegt im Nest. And this is exactly what I'm talking about here. The method filter, it has never been defined on Enumerable. Enumerable doesn't have a method which is called filter, but now it has. Because using this keyword, we inject a new method into an existing type, and in our case an interface. So now we can just write numbers.filter just if filter would be a type in Enumerable, although there isn't. Get it? Now, what is the result type of our filter method? Enumerable, right? What did we do with the injection? We injected the method into Enumerable. So what can we do? We can now chain these methods. Get the idea? Numbers was an array of number. By applying the injected filter method, we return an Enumerable. And where did we inject the filter method? Into Enumerable. So we can chain this filter method. In this case, it just says filter based on the modulo operator and filter based on the lower than operator. And because this is a so-called generator method, which always returns just one number, the system works as follows. It takes the first number, sends it to the first filter. Then it takes the first number, sends it to the second filter. So the first number completely walks through the entire chain of method calls. And then we have the second number, the third number, the fourth number. So the memory footprint will be minimal, even if we have millions and millions and millions of these numbers. You get the idea? And now I'm happy. Now I'm happy. This is now a really nice method. Granted, maybe you wouldn't have come up with this method immediately. You need a little bit of imagination and a little bit of knowledge about C#, but I think you get the point why you should do something like this. And now I have very bad or very good news for you. It depends on the point of view. We can delete our entire code because this already exists. Microsoft has already written a lot of functions like this. And Microsoft called this stuff LINQ. Using system.LINQ. Language Integrated Query. Essentially, language integrated query is nothing else than a bunch of injected methods on IEnumerable. That's it. The method in LINQ that we just implemented is called where. Not filter, it's called where. But it's exactly the no, it's not. They have a more complex implementation. But idea-wise, it's exactly the thing that we developed. So now we can get rid of all this stuff. We don't need our filter method anymore. I have it on video, so I can give you the video if you want to recap it later on. And I can just here remove it, and I now have the where clause. LINQ, language integrated query, allows you to very easily do, for instance, filtering, as you see it here, with the where clause. And I would like to spend the last 10 minutes or so that we have to show you a bunch of additional methods that LINQ can provide, which are very, very, very useful. First, let me quickly clean up a little bit. I like the where clause here. That is okay. I want to get rid of the second where clause. Let's call this result. And let's iterate over the result. And in this case, my program should be cleaned up, so it should work again. Let's see. And come on. Come on. I need a climate control for my computer. Come on. Yeah, now it works. 2, 4, 6, 8. It works perfectly fine. So where is one method. There are additional methods. The next method, result equals numbers. The next method that I would like to introduce to you is select. It projects a value. Number goes to number multiplied by 2. So what you can easily do, you can iterate over a collection and change the values. So the result will be what? 2, 4, 6, 8, 10, and so on. Get it? Of course, you can combine this stuff. You can say, okay, numbers dot select, and at the end, you can simply say where and so on. I think I don't need to emphasize that. Clear? Next one. By the way, here you see all the different things that you have. Okay. The next one that I would like to show you is first. Oops. If my laptop is so slow, typing is slower than so. In contrast to select or where, the return type of first is not a collection, but is a single item. Essentially, what we say here in line 18 is, give me the first number of numbers where the value is greater than 4. So in our case, the result will be 5, right? What would happen if I do something like this? The result will be an exception. Why? No, there is no number greater than 99. That is why there is the next method, which is called first or default. However, first or default will not return, well, yes, it will return integer, but what will it return if there is no number greater than 99? The default value of integer, and what is the default value of an uninitialized integer? 0. Get it? There is another method which is called single. Single means give me a single item fulfilling this condition. That's fine. I would get 6. This would end up in an exception because there are more than one items that fulfill the condition of being greater than 6. So first, give me the first, and single makes sure that I get the item, the one and only item that fulfills this criteria. And if there are more than one item fulfilling this criteria, single will return an exception. There are a few additional methods which are really useful when it comes to calculating things. I can say single result equals to numbers dot, for instance, sum. Sum is also a method from the LINQ area. Do you understand what it does? Well, it calculates the sum of the values. And similarly to sum, there is a min, there is a max, there is an average, and things like that. You get the idea? If you have a more complex object, think of the following. Var orders, new array, something like this. And inside of the array, we have new object. Let's call it product 1 and price 10. Yep, something like this. And then we have a bunch of products here, 2, 3, and 15, and 20, for instance. Something like this, and something like this. So, what is if I would say orders sum? What should be the sum? You get the idea? How can I sum up orders? It doesn't work. However, I can do something like this. And now I think you get the price. Give me the total sum of the price of each order. Pretty nice programming model, isn't it? And now you see why these lambda functions are so useful. Imagine that for every of these small little lambda functions, you would have to write a fully blown method with a function body and a return type and writing return and the curly braces, and your code would be cluttered. With that, it looks really nice and really clean. So what should you remember from this? Yeah, it's nearly done. From this 1 hour of live coding in C#. First, you have learned that you shouldn't write spaghetti code. Single responsibility pattern. We separated the method from which we started into multiple pieces. Next, we replaced the hard-coded is-even method with a strategy pattern. I told you something about Kuckuckseier, about extension functions. Remember this stuff. And at the end of the day, I told you that there is something like system.LINQ where you have methods like where, select, single, sum, and so on already built in. So this is the most important message that I would like to give you. In many cases, using system.LINQ is really useful because it will inject, Kuckuckseier, it will inject all these useful methods into your collections. But for that, you need to do using system.LINQ. So whenever you need to calculate the sum, get the minimum value, get the maximum value, do some filtering, do some ordering, group by, all the things that you have learned in SQL, in the structured query language, they are available in C#. This is the reason why it's called language integrated query, and they are hidden behind SQL.LINQ. Good? Clear so far? Good. I hope it was an interesting cover lesson. I hope you learned something. I hope it will help you in the future. And with that, I would like to close for today. Thank you very much.